Hi students, this is Mr. Yao. Today we're going to continue to learn more about how to write exponential equations from graphs or functions from graphs. Prior knowledge is something that we have been writing for a few times already. The exponential function form f of x equals a times b to the x power plus c. A is the initial value, b is growth or decay factor, and c is the vertical shift. We look at growth or decay from the graph. And if the graph increases from left to right, is growth. If it decreases from left to right, is decay. In the previous lesson, we dealt with when c equals 0, or in other words, when the asymptote was just y equals 0. So the form of the function became a times b to the x power, since c is just a 0 on the end. In this lesson, we are going to expand that understanding. So this time, the vertical shift won't be 0, so the asymptote won't just be our x-axis. So, steps. Steps to write exponential function. In today's focus, we're focusing again on c does not equal to 0. So let's first have a look at an example. Let's pretend that you didn't notice, because here's the thing, when you're given a graph, maybe you forgot, you actually need to do something because this does not look like c equals 0. Well, let's say you actually forgot. Then you might be able to actually start writing down some points. Let's actually label some points. The first point, well, we can see right here for sure, we have 0, 1, but we need to actually read from left to right. So we have another point over here. And then we have, let's see, that one looks like it's on 18. There you go. So these are the points we may actually have. The point is on 17. It's not super clear, but it's actually on 17. Okay, so let's actually write these points down. We have -2, 17, and then we have -1, which is at 5, and then we have 0, which is at 1. And we don't have other very clear points anymore. So let's say these are the points you found. In the last lesson, I did recommend you actually check the factors for two pairs of numbers. So if you use the bottom number divided by the top, 5 over 17, or you can't simplify it, then the other is 1/5. This is where you may notice, wait, factors are not the same. Well, then that means there's something that you have missed, which means the c does not equal to 0. So this is how you could know that c does not equal to 0. Okay, so now let's talk about, after you notice that c does not equal to 0, the factors won't be the same if you just get the points. Let's see what we need to do. Step 1. Find the c, which is the vertical shift from the asymptote. So previous lessons, when you were given a function, you actually identify the c, then use the vertical shift to find the asymptote. But in this case, you are given the graph, so you should be able to clearly see what the asymptote is. So the asymptote is right here on this bottom line, because our graph is getting super close to that. And that asymptote, let me actually write it down, is at y equals -1. So that tells us the c is actually a -1. That's the first thing we do, find the c, vertical shift from the asymptote. Then the second thing, we are actually going to move the graph. We're going to move the x-axis to the asymptote. And if you want to relabel all the y-axis, you can do that. But this is going to become our new x-axis. Right here. This is our new x-axis. We don't actually need to do anything to the y-axis because, well, vertically it doesn't actually affect much because the graph is actually being moved up or down. So we are moving the x-axis to accommodate that the graph was moved. Okay, now that is our new x-axis. And when we say if you want to relabel the y-axis, well, that's just saying these 2, 4, 6, 8, 10, 12, all of these numbers are going to change since this purple line now is our new x-axis. So the 2 would actually be here, and this is the 4, this is the 6, this is the 8, that's 10, that's 12, that's 14, that's 16, that's 18. So if you want to relabel, you totally can. Next, based on this new xy graph, we're now going to identify the points again. So let me actually draw the points again. This is our first point, and then we have another point right here, and then the point right there. So based on this new xy graph, we are going to use the new x-axis to write down the points. The first point in this case is at -2, well, the new number is 18. Okay, next is at -1, which the new number is 6. And when it's 0, is actually at 2. There you go. And now we are actually going to repeat what we have done in the previous lesson. So after we write these numbers down using the new xy axis, we're going to repeat. So next, we are going to find the factor. Now you see, if you use the bottom number divided by the previous number, 6 over 18, that simplifies to be 1/3. 2 over 6, that also simplifies to be 1/3. So this is why we have to check two pairs of numbers so that we're very clear on if c is equal to 0 or does not equal to 0. So now we know the factor has to be 1/3. And after we find the factor, the next thing we do is we are going to find the initial value, which is our y-intercept. But this y-intercept, again, is our new y-intercept based on this new xy graph. So it's right here. When x equals 0, the y value is going to be our initial value. So it's 2. The graph looks like it's going down. It's decreasing to the right. So it's going to be decay. And when we write the function, the difference is now we do need to actually put in that c. So the function is f(x) equals 2 times, don't forget the parentheses around the factor, 1/3, to the x power, then don't forget the -1 on the end. So it's a little bit different. We have this extra step that we have to move the xy axis. So that is example 1. Now let's go through another one. Example 2. Same thing. Let's first pretend that you didn't notice that you need to actually change the xy graph. So let's see. We have a point here that looks like a clear point. Then we have another clear point right there. And then last point right there. So let's say you actually found these points. Let's write it down. It's going to be 0, 3. And then the next one is 1, 8. And the next one is 2, 18. Well, let's see. 8 over 3, that's the first pair. And the next pair is 18 over 8, which simplifies to be 9 over 4. Well, clearly they're not the same number. So this is how you know, wait, there's something happening. I need to move my axis. So let's move the axis. First, we identify the asymptote. The asymptote is at y equals -2. So that means my vertical shift is a -2. And I can totally relabel everything. So this time the whole thing is moved down 2. So based on if this is like my new x-axis, this is my new x-axis, that's 0. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now based on that, I can actually write down the points. The first point we see is 1, 2, 3, 4 is actually at 5. So that's 0, 5. Next point is actually at 1, 10. And the next one is at 2, 20. So now if you actually try to find the factor 10 divided by 5, 20 divided by 10, they're both going to equal to 2. So the factors are actually the same. So the factor is a 2. And then to find the initial value, we need x equals 0. The y value is going to be our initial value, which is 5. And in this case, you can see the graph is increasing to the right, so growth. As for the function, let's write it down. A is 5, so it's 5 times. B is 2, so it's 2 to the x power. C is -2, so it's a -2 on the end. There you go. That's example 2. Now you can pause here and keep trying for the next few examples, and then come back and check. So, example 3. Now that you know you do need to actually move the x-axis, because clearly there's an asymptote. So let's move it already. This is our asymptote. This is our new x-axis. The asymptote was at y equals 2, so that means my vertical shift is going to be a 2. Now based on that, I can relabel everything. So if this is my new 0, that will become -2, -4, -6, -8, -10, -12, -14, -16, -18, and -20. Let's identify the points that we can see. This is a very clear point, which is at 0, -2. When it's at 1, it's also pretty clear. It's at -4. Well, we even have another point on -1, so you can also write -1. If I can move a little bit. When it was -1, it's actually at 1. And then when it's at 0, it's at -2. And then when it's at 1, it's at -4. Next number we see right here, when it's at 2, it's -8. And lastly, when it's at 3, it's -16. You can check -2 over 1, which is well, actually, that's at -1. Sorry, over what? -1, that's a 2. -4 over -2, that's also a 2. -8 over -4, that's also a 2. -16 over -8, that is also a 2. So our factor 2. Initial value, when x equals 0, the initial value is -2. The graph is going down, so decay. F of x equals a is -2, b is 2 to the x power, and c is a 2 or plus 2 on the end. That's example 3. Moving on, example 4. So this time, my new x-axis is right there. Originally, the asymptote was at 2, so that means the vertical shift is a 2. So we can relabel. That will become our 0. So -2 is right here, -4, -6, -8, -10, -12, -14, -16, -18, and -20. Let's find the points. The first point, well, we already know there's a point right there. Then there's another point right there. Here again, and keep going down. And then we have right here. So when it was at -5, we were at -16. Okay, and then when it was -4 is -8, -3 is at -4, -2 is at -2, -1 is at -1. So the factor is pretty clear. -8 over -16 is 1/2. -4 over -8 is also 1/2. -2 over -4 is 1/2. -1 over -2 is 1/2 again. So the factor is 1/2. Now we need to identify the y-intercept, which will give us the initial value. So based on this pattern, it's actually being divided by 2 to get to the next number. So we're going to need to divide by 2 or multiply with 1/2. That's how we get to the next number. So we need to multiply by 1/2 again. That means when x is 0, it's -1/2. So our initial value is -1/2. It's going up, so it's going to be growth. The function is -1/2 in the front, and then times b is 1/2 to the x power plus 2. But don't forget, put parentheses around the fraction. That is example 4. Moving on, example 5. Okay, -2. Well, first we need to move our x-axis. Originally, it was y equals 1, which means our vertical shift is going to be 1. So we can actually identify the points now. Everything is basically moved up by 1. Or, I mean, when you try to label it, the numbers are going to get smaller. So instead of this being 2, 2 is right here, then 4, then 6, 8, 10, 12, 14, 16, and 18. There you go. So these are the numbers. These are the new numbers. Let's use the points. When it's at -2, it's actually at 16. When it's at -1, it's actually at 2. So this won't actually be 5, 4 because we have moved the axis. So you can see the factor is 2 over 16, which is 1/8. Okay, we already know this has to be because we have already moved the axis. Okay, so that means in order to get to the next number, I need to multiply by 1/8. 2 times 1/8, that is 1/4. So my initial value right here, 1/4. It's going down, so it's decay. F of x equals 1/4 times 1/8 to the x power. Again, don't forget the parentheses, and plus 1 on the end. That is example 5. Moving on, example 6. Same thing, let's move the axis. This is our new x-axis, which originally was at -1, so our vertical shift is -1. Let's relabel the axis so that we can actually find points. So the 2 would actually be here now. This is 4, this is 6, that is 8. Okay, let's put the points down. This is the first point I see, which means when x is 0, my y is 1. Next one I see is right here. When x is 1, my y is actually 3. And the next one is right here. When my x is a 2, my y is a 9. So the factor 3 over 1 is 3. 9 over 3 is a 3 as well. The factor is 3. Y-intercept, when x equals 0, my y is a 1. So initial value is 1. The graph is going up, growth. The function is 1 times 3 to the x power minus 1. But typically in this, if it's a 1 in the front, it's multiplication, we don't have to write it. So 3 to the x power minus 1. That is example 6. And that is everything for this lesson. Thank you.